on our graduate pathways presentation. We have a few faculty here to join to present on their programs and their expertise. And we're going to start with Dr. Joseph Pillay, who's our ECEE Graduate Program Chair.
Hi, students. Glad that you're here visiting with us. I am the Graduate Program Chair, and this is my name. And the other important people in the graduate program in terms of advising you are the graduate advisors. You'll hear from Lynn a little later today, and but Tony and Snow are also under the advisors. But what I'd like to do is convince you to go on to graduate school, whether you stay here face to face, take the classes online, which we allow for the master's degrees, or go elsewhere. It's really important that you continue on with your education, if at all possible, and if you're going to stay in electrical engineering. Most students do stay in engineering and in electrical engineering, but a few take some other paths to a career. Okay. There are a number of fellowships available for the PhDs. There's the University Graduate Fellowship, which they get an RA, quarter time is 10 hours a week, and plus they get $18,000 grant from this fellowship. I'm just going to give you an idea of what these fellowships are, because if you do go to graduate school, you can expect to have all of it or a great deal of it paid for. The Dean's Award is our best award, $30,000, and it's guaranteed for 4 years. The Fulton Fellowships are for PhDs, and they are $3,000 to $5,000. They are just an add-on to any other funding you might have. In general, we have RAs and TAs. Now, the teaching assistants, TAs, I handle those, and I appoint them each year. So some of you could get funding from that. The RAs are given by the individual professors. RAs given by the individual professors. The funding is the same for the TAs and RAs. For full RA and TA, you get something a little over $18,000. That's a full year, plus your tuition. It's if you're out of state, it's the out-of-state tuition. If you're in state, it's the in-state tuition. The ARCS award is an award of $8,500. There's nothing attached to it. There's no requirements for you, but this is awarded to people that are in their second year into their PhD or something, or somewhat beyond that. And if you finish your PhD, you have the Outstanding Doctoral Award, which I happen to be the person paying for that, but this is really for our very best of the best students. Now, what I think you ought to do if you're undergraduates is certainly look at the master's degree, because if the master's degree, if you get it, you probably have about a $10,000 difference in entry salary. There are some national publications that look at the master's degree, and they have rated us for our online program the third in the country. They have rated us for the online, for the on-campus program, somewhere in the better than 30, depends on which evaluation you look at. And then this right here is the fellowship page, and this is not on electrical engineering. That's why I want to put it up here, and you can get it from the advisors as well. It's on the page where the Fulton School of Engineering is, because they give the fellowships for all the different schools. There are 6 schools within the Fulton Schools of Engineering. So you might have missed this right up if you were only looking under electrical engineers. Okay, that is then the finish of my presentation. Thank you very much.
Thanks, Dr. Pillay. So as students, as you can see, there's lots of options for PhD fellowships and support. And we'll describe our master's programs a bit more in just a bit. Our second presenter is Dr. Reislein. He's the program chair for the computer engineering master's and PhD programs.
Yes, so can I then share the screen?
Yes.
Okay, good. So let me go ahead here. I have two files that I'll show. First here. This should now show the presentation, hopefully.
Yes.
Yeah, good. So I'm Martin Reislein. I'm the program chair for computer engineering. As you see on the slide, the computer engineering program at ASU is a interdisciplinary program supported jointly by computer science and electrical engineering, as you see here represented by the two buildings. In its spirit, it's really a transdisciplinary program that bridges both computer science, computer engineering, and then electrical engineering to make this bridge. So it's about all the skills that you need to work at this intersection of computer science and electrical engineering. And since Professor Pillay fortunately pointed out all the good things about funding, support, importance of graduate school, and so on, all those things apply also to the computer engineering program. So I will build on that and explain a bit more about the novel features and aspects of computer engineering and why this is an exciting program to consider if you graduate now soon from the electrical engineering undergraduate program. To do that, I'm going to show you one other file that maybe gives a better sense of the exciting things that are going on in the computer engineering field. So I'm pulling up this PDF file. Hopefully you can see, where am I now? Too many files. Can you see the PDF file now? I should show a figure one with some graphics.
Yes, we can see it.
Okay, good. So there's a more recent article that I published with actually a former PhD student of mine, Dr. Akhilesh Gaduru, who is now working at Intel Corporation and in Chandler. And we have been looking at the computer engineering field from perspective of supporting communication networks. Communication network is my personal research interest, my specialty. And so I look at computer engineering in my own research from the perspective of supporting the internet, specifically in communication networks, wireless networks, and everything that goes with it. And to illustrate what computer engineering is about, I'm going to show here real quick the challenges that are being faced by modern communication network equipment. If you think of the old days, you had dedicated routers from Cisco, other providers. There were dedicated machines. Nowadays, the trend is to more flexibility and pushing out networking capabilities to the edge of the network. If you think of streaming services, wireless networks, these all work smoothly nowadays and everywhere because resources for switching and networking are being pushed out from the backbone networks into the edge networks, so closer to your house. And in order to do that, you have to run communication network functions on general purpose CPUs. So you have to retrofit CPUs, just plain old CPUs with networking accelerators. And that was Intel and other manufacturers are doing. And so this shows you now like an illustration of you can build around a CPU, several CPU cores, accelerators that accelerate network functionalities. And there's several levels to it. There's a physical perspective to it, but also in terms of the software, the modules that are running on it, you can virtualize and containerize the various functions. It becomes an interplay of software and hardware. And that is the essence of computer engineering, that you really need to always keep in mind the hardware support underneath and the software that's running on top of it and how those two interface. And you really want to push those corner cases where you can optimize software running in very restricted hardware. So this is the essence of computer engineering, how to make those two work together smoothly. And I want to show you a few more illustrations that everybody is working on this. And I show a few images here of typical state-of-the-art processors that are focusing on this. So here you have an illustration of an ARM processor. You see here various specific acceleration modules that are focused on making this networking faster and more flexible. ARM is not the only one. There's also, of course, Intel. Intel is making the Xeon CPUs faster, and AMD is doing the same thing, and Amazon has their own processors, and it goes on and on. So everybody's doing this. Any questions on this? Anybody? So this publication is available online for free if anybody is interested. But let me stop here and go back to the slide. Here, where do we have a presentation now? Where is the presentation? Yeah. Yeah. I need to now pull up again the presentation. Where is the presentation? I have, where is my presentation now? I'm a little bit lost. Oh, yeah, here. Okay. Okay, I want to share the other presentation now. Sorry about, okay, now I got it. Okay, good. So back in the presentation. So in order to make this work, the two courses that you need, and this is something to keep in mind now as you prepare for graduating and working towards graduation, you need to take a random signal theory in your graduate program. And this is one of the two core courses. And coming from EE, you will be prepared for this. The other challenge that you're facing, and that's important because it's a transdisciplinary program, is Foundations for Algorithms. So it's a CSE 551, and talk to your advisors early if you're considering computer engineering to get the background in data structures and algorithms, so you can then successfully take Foundations for Algorithms as you go on into the computer engineering program. The computer engineering program at ASU has 5 areas that are defined here. It's autonomous systems, robotics, and it goes around all the way to communication networks. And those areas have specific courses, and there's certain requirements as to courses you need to take in each of these areas. So there's certain depth and breadth requirements to fulfill. Going on, here's some fancy pictures that again illustrate the interdisciplinary nature of computer engineering. Many things come together, and this coming together of hardware and software and working within the constraints of the hardware arise in many situations, as you see in these illustrations. Of course, we have a master's program. I want to highlight that also here verbally. It's very flexible, also in terms of internships you can take. We have students going on very exciting internships all over the country, both in semester as well as in summer. And we have all the big players and all the little exciting new players, up-and-coming players in the market that take our interns. So it's a very exciting time. If you then are thinking of going beyond the master's, we have a computer engineering PhD program. It's also very exciting. It's very research focused. It's built to allow for your research to go on very smoothly with extensive independent study opportunities. So it's something I want to highlight here. If you have any questions, please don't hesitate to then contact me or our advisors with Araxi Omanasian on the computer engineering, computer science side, and then Brad on the EE side. Yeah. Any questions?
Hey, Lynn, I'm back. Sorry about that.
No problem. Thanks, Martin. I'm not seeing any questions in the chat. We will have time for Q&A at the end, and if you're not able to stick around, that's okay.
Okay.
I'll answer any questions and refer them to you if needed.
Okay.
We're going to keep moving along here. Thanks, Dr. Reislein.
Yes, thank you.
Next, we have Dr. Aberle, and he's going to, even though we're trying to convince you into graduate school, he's got some thoughts about some other options that you might consider.
But by the way, there is a question in the chat, which is how long does it usually take to finish a PhD? and I can give that a shot. So in my case, it was 4 years, but that was because I was full-time and fully supported, financially by the program that I was in at UMass Amherst. But some people, it takes longer, and there's a few that are superstars that might be able to do it shorter.
I have maybe the Achilles who I worked with on this one article, he did it in 2.5 years. But again, it depends on the background that you have. And if you have prior industry experience in your field of research, then it can go super fast. But yeah, more typically about 4 years, and it can go 7, 8 years if you go part-time. Yeah.
The institution analysis comes up with the average time it takes to get the PhD for all of our students, and it is about 5 years.
Mm-hmm.
Yeah, so it's quite a commitment on the part of the PhD candidate to get through it, and it is not it's not easy. It's a lot of research. It depends, and research is very open-ended with a lot of risks, and things may not work out. You may have to change your topic. The support for your project may disappear. So it's a risky thing.
Not really true. It's really a lot of fun, and a lot of people that you work with that are going to be lifelong companions in the work effort. And nobody ever says it's not what they want to do.
Yeah, I would agree with Professor Pillay. I think if I look back on the 4 years I spent pursuing my PhD, I made some really good friends, and I actually really enjoyed the experience. So yeah, and it of course it opened the door that I wanted to get through, which was the door into academia. So thanks for that. I guess it's thanks, Lynn, for answering those questions. I guess it's my turn to speak. And before I speak, I do want to thank all of you for attending. And in particular, I want to thank our advising staff who have really done a great job in helping guide our students and us professors through this situation with the pandemic, and they've been great support to us. So I want to thank all of them, and also thank the students for attending and showing interest in this stuff. So I'm going to share my screen. I just have a couple of bullet points on a PowerPoint that I would like to share with you just to make sure I cover everything I want to talk about. And I wonder sometimes if I should be the first one to speak at these things, because one of the questions that I think you really need to ask yourself as you're completing your BS-EE degree is, do you really want to be an engineer? So when I recommend that you ask yourself this question, it's not, I'm not trying to tell you, well, stop going for your BS-EE and do something else. I think you've already made a really substantial commitment to completing that degree. And I think that degree opens a lot of pathways for you that don't necessarily involve actually going through and making a career in engineering. And one of the things I want to say that I know from experience is that life is short. Yesterday I was 25 years old and today I'm 60 years old. So, it goes quick, and you really need to enjoy what you're doing. If you like engineering, then stay with it by all means. And I happen to be a person that really liked engineering. I mean, even before, even as a child, I liked doing things. And I think I'd like to claim that I had the knack. And I don't know if you know that reference, but that's to Dilbert, where the mother brings Dilbert into the doctor and tells the doctor, my son really enjoys taking things apart. And the doctor says, well, that's perfectly normal for a child. And the mother goes, yeah, but you don't understand. Then he puts them back together again and they work. And the doctor, of course, is like, well, he's got the knack. But some people pursue, you know, it was very natural for me. There was no doubt in my mind through high school that you know, I would be an engineer, and and in particular an electrical engineer. But for some, you know, you may be pursuing a BSEE for other reasons, you know, family pressure, you know, just, you know, you're steered that way by a high school guidance counselor who told you that, you know, it's a, you know, you're good at math and science and this is a good way to make a living, etc. So you really need to examine your reasons for, you know, why am I pursuing this degree? Do I enjoy what I'm working on? And, you know, do I get excited about some of the homeworks and some of the projects that I get to work on, seeing, you know, do I find it gratifying, etc. And I just want to tell you that I know a lot of students and a lot of other people in my, you know, personal and professional life that did get bachelor's degrees or even more advanced degrees in electrical engineering. And they went on to do other things. Several people I know became intellectual property lawyers. And, you know, at one time that was, you know, a really, really good job. But I think intellectual property lawyers have become a little bit overrepresented. And I hear it's not as great of a living as it once was. But nevertheless, if you're interested in that sort of thing, then that's something you could pursue. I know one person who actually earned a PhD in electrical engineering and then later in life became a criminal defense lawyer. So that's, you know, that possibility exists as well. I know several who became medical doctors. So if, you know, if you may decide that medicine, and in particular, I've worked with some doctors, by the way, on some projects, one in particular who was a pediatric neurosurgeon. This guy understood, he'd gotten a degree in electrical engineering, was very interested in devices. This guy really understood electromagnetic fields and things like that. So, you know, just a brilliant person, and decided, you know, to pursue a career as a medical doctor. By the way, I have one student now in senior design who is already an intellectual property lawyer and come back to get a degree in electrical engineering because he likes it. So that's that happens too. I know several who have become venture capitalists. Now, frankly, the two that I know that became venture capitalists had a head start in life coming from wealthy families. So I'm not sure that, you know, that's not really a career path unless you already have the financial backing to do that. And I work with some professors in the School of Earth and Space Exploration who got degrees in electrical engineering and then advanced degrees in physics and work in the area of physics and astronomy, in particular radio astronomy, because that's, you know, very, very electrical engineering related. And of course, there are some people who don't completely change directions, but rather become managers of engineers. Some people are more interested in project management. And I can see that in teaching senior design. You see that some students just do really well at organizing the team and assigning tasks and maybe doing a little bit of tasks themselves, but mainly directing other students to do it and keeping everything, you know, on track and you know, understanding what's, you know, the deliverables are when they're due, etc. So many, and in that case, you know, if you became a manager of engineers, then an MBA, Masters of Business Administration, is a natural degree, you know, advanced degree to get. So let's talk a little bit about advanced degrees in engineering. So suppose that you decide, yeah, you know, I really like this stuff. You know, I worked on my 433 homework and I got real excited about the problems, and, you know, I really liked my senior design project. And you decide, you know what, I want an advanced degree in engineering. Of course, you've also got to have the grades to back that up, as well as the interest and the motivation. And I would say that, you know, in my opinion, in my experience, if you want to have a technical path in your career, then I highly recommend, I would even say it's a must, a master's degree. you really need to see how all of this things that you learned as an undergraduate have can come together and really do an in-depth academic investigation and understanding of this material. So I would say a master's degree is a must, and it also will give you the credentials you need to keep working on a career path. Now, the PhD degree, this is something that, you know, I have, Professor Pillay has, Professor Reislein has, all of the faculty have. I really have to say that, you know, you work on something very intensely, a particular topic, so you end up knowing a great deal about very little as a result of your PhD. And it really is only essential for an academic career because, you know, part of the academic career is that you're publishing papers, you're doing research, you've been through the process of being a graduate student directed by a professor, you understand something about how to get funding. So I would say that a PhD degree, although there are people in industry who do pursue it, and it does in some instances open doors for them, I would say it's really only essential for an academic career. And I can tell you, I earned my PhD in 1989, and everything I did as part of my research over 4 years could probably be reproduced by a senior design student in a week or two right now. I worked on algorithms for analyzing a particular type of antenna called a microstrip patch antenna. And now there are simulation tools that can generate those results more accurately and faster and design the things that I was designing and, you know, the hardware that I was constructing and verifying very, very quickly. So again, the PhD, I would say is, you know, some people like the thought of having that credential, but that credential, as far as I have ever seen, the only roadblock it overcomes is the roadblock into becoming a tenure track professor at a good academic institution. By the way, some electrical engineers choose to get they like engineering, but maybe something somewhat outside of electrical engineering, like biomedical, for example, has excited them and they decide to pursue a graduate degree in another engineering discipline. So that's also a possibility. And of course, I mentioned this previously, if I would consider a master's, you know, an MBA with an electrical engineering, and there's combined MBA, MS degrees as well. But an MBA is a degree that is probably critical if you want to pursue the path of engineering management and move up the corporate chain, you know, the corporate ladder. One of the things that we could also talk about too is the sorts of organizations that electrical engineers end up working for. And of course, there's corporate America. So there's, and in corporate America, you know, that those corporations can be classified as large, medium, or small. They can be classified as commercial or defense, you know, government or commercial, you know, consumer, I should say consumer or government. And under government, there's both, you know, something like NASA, which is a, you know, a civilian activity, and there's also defense activities. Some go into academia, and there's all sorts of, you know, some work for the large, you know, especially if you would do the electrical power option in electrical engineering, you might go to work for the large power companies locally, like Salt River Project or APS, et cetera. So that's another choice that you need to make. If you decide to stay in engineering, if you decide to do a work for an organization, then you need to understand what type of organization you'd like to work for. What are the advantages and disadvantages? You know, I would recommend not working for a startup company right out of your degree because, you know, a startup company is very risky. You're not building retirement. You know, the benefits might not be that great. It's a high risk situation. et cetera. So I think I've probably talked more than enough of more than my fair share. But I would be happy to, answer any questions you have now, or feel free to reach out to me by, by email, and or go through the advisors, whatever you're most comfortable with, and we could certainly chat more.
Hey, Dr. Aberle, there is a relevant question right now. You touched on this, but maybe Colton is asking, do you think there's a real benefit to pursuing a PhD instead of a master's if they want to go in industry after school? So you touched on that, but do you have anything else to say about it?
So I think that, the master's is usually something you would be a step in the process of getting a PhD. So I'm not sure that, the phrasing PhD instead of a master's would probably be a PhD on top of a master's. Now, as far as industry, I don't really think there's an advantage of getting a PhD over a master's, to be frank. Some people, there may be a few very nuanced situations where that's true, but I would recommend, so what I did, I can tell you from my experience, I finished my bachelor's degree. I went to work full-time pursuing a master's degree part-time. Then I completed that master's degree and decided I wanted, academia was exciting to me. So I applied for and was accepted into a PhD program. And I left the job that I was at and went for the PhD. So I don't know if that really, that's just my experience.
Yeah, I'd like to add something to that. There are a number of large companies, Intel being a good example of that hire PhDs. And we've had all of our PhDs have been, more have been hired by corporations than have gotten into academia. So you may or may not be able to get into academia. You may or may not want to be in academia, but with the PhD, there are a number of corporations, particularly to do their high-level research and even to lead their programs. I see Lynn nodding. She probably talked to some of these people that as they graduate and they're going out to the companies. And so it really is a pathway for them. I want to acknowledge Jim for mentioning all the ways you can use electrical engineering degree undergraduate in other than electrical engineering. And so these people are going to spread out into other things. But that actually is true. There's not, I'll add something to what he's been saying. There's no way to know what you will do in 5 years. If you were to write a plan, we always teach you, you ought to write a plan, have goals. If you write it out for a 5-year or 10-year plan, there's no way that that's going to be come to fruition. And that's been experience. That's been my experience, both my own education and my own work at the university. By the way, I picked electrical engineering because in the days I was going there, you had lines and with signs on them. This is electrical engineering. They didn't have a computer. This is mechanical engineering. This is aerospace. So I took the shortest line. It did, and it turned out well. So there's no way to really plan those things. But whatever you choose, do it well, and then you will be successful. Thank you.
Thank you very much for these great answers. We'll pass it on to Lynn Pratt and Annalisa Margarble, who are going to talk a little bit more about our 4+1 program.
These are great questions, everyone. And we'll also have time at the end for Q&A. I am going to go pretty quickly here through some grad school information, and then Annalisa is going to talk about 4+1. And then after that, we're going to hear from Dr. Redcar about the robotics program. So here's a quick summary of the programs that you're going to hear about today. So we have, of course, the electrical programs, the MSE, that's the 10 classes. and the written comprehensive exam. That's the default for all of our master's students. You can change to thesis after your first semester. You could also do a direct PhD. And so that means you're going directly from your bachelor's into a PhD. And you do have the ability to earn your master's along the way in that program. We also have the computer engineering program that you've heard about from Dr. Reislein. You can also do the direct PhD and earn your master's along the way there. So this is a common theme you're going to hear from us. No matter what, we have an option for you. You're not going to be lost in programs and have no options. You have a way to earn multiple degrees from us. We have the robotics engineering program that is currently only a master's. I believe the faculty are in talks of adding a PhD in the future, but right now it's just a master's. And this is a unique program that's shared with 5 schools now. So the computer engineering program is shared between 2 schools and robotics is shared between 5 schools. That's really unique because it gives you the opportunity to take classes from multiple schools within engineering. So Dr. Sangram's going to talk about that next after Annalisa, but this is definitely a program you'll want to consider if you have a lot of interest within engineering. So we're going to quickly go over some 4+1 options. We also have webinars every month, multiple times a month that you can sign up for if you'd like more in-depth information about 4+1. But it's just for the master's programs. So you share credits between your bachelor's and your master's programs. So the EE is offered online. So Chris, like just how you mentioned, unfortunately, most of the programs are only offered in person. Yes. Right now, only our EE, BSc, and MSc is offered online. The computer engineering and the robotics programs are only offered in person.
All right, so I'm going to talk about the degree requirements for the EE/BSc and MSEE. You need to select an area of specialization at the time of application. For online students, you can choose 5 out of our 6 areas of specialization. Control is currently not offered online. And for on-ground students, you can choose from all 6 areas. Your comp exam will be based on this area's specialization. That's why it's important when you submit the application that you do know what area you want to specialize in. Pardon me. Your time to completion can be as quick as 1 year after graduating with your BSc, or you can go more slowly if you're working full-time, if you're an online student working full-time, as long as you're maintaining continued enrollment status. For the CEN master's degree that Dr. Reislein was talking about, there are 2 required courses and then 4 area courses. You can choose a comp exam or choose the thesis option. And again, it takes about 1 year after graduating from your BSc. If you choose the thesis option, because you're doing research and working with a professor, it may take an additional semester or 2, depending on the nature of your research. And then finally, for the RAS, as Lynn alluded to, it's a multidisciplinary program. We've got 2 required courses and then several core courses and classes outside of the EEE prefixes that you're used to taking. It's a very exciting program if you are interested in robotic and autonomous systems. For that one, also, you can choose either the comp exam or your thesis. So I am the 4+1 coordinator. I will be the one that you will be communicating with if you're interested in applying for the 4+1 program. We have very strict GPA requirements. We're pleased to announce that it is now a 3.25 cumulative or major GPA if you're interested in the MSEE program. For the CEN, which again is on ground only, 3.0 cumulative GPA. And for the RAS, some more exciting news. The 3.5 cum GPA requirement will soon be changing to a 3.25. So we look forward to welcoming more of you into that program. In terms of when should you apply, Typically, you want to have at least 90 credit hours completed and be in the semester before you start 488 senior design. Some of you may want to start though in the summer and start with a tech elective, and that's perfectly fine too, as long as you meet the GPA requirements and the credit requirements. So how does the 4+1 program work? What's the magic here? What's this all about? Well, basically you are going to be sharing classes that count toward both of your degrees. So in theory, double dipping, allow double dipping. And then if you wish, you could also reserve a class. Now that class will not satisfy any of your BSc undergraduate requirements, but you would take it as an undergraduate and it would just sort of hang out there and be counted toward your grad degree once you complete that class. There are strict rules regarding sharing and reserving. As you see on the slide, most important, you cannot exceed 12 credits of sharing and reserving. So you can't double dip more than 9 credits, and then one of them you could potentially reserve if all 4 credit classes are going to be 3 credit courses. Clear as mud, everybody? I hope. All right, how and when to apply to the 4+1? So again, 90 credit hours, and typically it's the semester prior to starting 488. But again, if you're thinking about taking a TE in the summer, I would encourage you to apply to start in the summer. The July 1st deadline is for the fall semester start, December 1st for a spring semester start, and for May, I'm accepting by May 9th for a summer semester start. How do you apply? Well, you can first check out the application form you'll find on this hyperlink and view the sample plans of study. List the 10 classes that you will take toward your master's degree, and then email your completed or your work in progress application to me. My name is on the bottom left. Lynn Pratt is our coordinator senior for the entire grad program. She's the one who will be happy to answer any questions about the BSc to PhD, to the traditional MSc, and to the PhD program. Just know, if you are interested in applying to the 4+1 web program, I do urge you first to sign up for the webinar. I hold up to 4 a month, every month. During registration, I hold maybe 3, but call up our front office to sign up for an upcoming webinar. It'll at least introduce you to some of the vocabulary and some of the options you may have as an online and or on-ground student. After you attend the webinar, then you'll be able to really ask questions that will affect your own personal situation. This is our ECEE advising. You can schedule an advising appointment with me after you attend one of the webinars. If you have additional questions, I'm happy to talk to any of you.
Thanks, Annalisa.
Yeah.
Yeah, so students, in a nutshell, remember, if you're a thrifty student and you're thinking about a master's degree, don't forget, if you're eligible, you can share classes between your undergraduate and your graduate program. That's where the +1 part comes in. It saves you time and money, and it gets you the same degree. Also, if you are enticed with a job offer when you graduate, don't forget about the online program. Many of our online students work for large companies that are paying for the students to get their online master's degree, and it's the same degree. Besides the controls area, as we pointed out, we don't quite have that online, but it's a great way to get some of your money back. Next, we have Dr. Sandgrim Redkar, who's the program chair, graduate program chair for our Robotics and Autonomous Systems program.
Thank you, Bob. I'm gonna share my screen. Okay, welcome everyone, and thank you for the opportunity to talk about MS in Robotics and Autonomous Systems. So as an electrical engineering graduate, you have quite a few options to pursue your graduate degree. And MS in Robotics and Autonomous System is one of those options. It's very exciting. As you can see that the world around us is changing. We call it Industry 4.0. And this is sort of the fourth industrial revolution where AI, robotics, and advanced manufacturing is booming. So if you are interested, I would encourage you to take a look at our website and look at the program. MS in Robotics and Autonomous Systems program is actually an interdisciplinary program, and currently 5 concentrations are available. And as an electrical engineer, you can pursue MSRAS as a 4+1, or what you can do is after your bachelor's, you can apply to MSRAS as a regular degree seeking student. Now, the 4 concentrations right now that are offered, the 5th one is in process, MAE, Systems Engineering, Electrical Engineering, and AI. As an electrical engineer, if you want to pursue MS in robotics and autonomous systems, there are few core classes and there are classes outside your concentration. The program is fairly flexible and it allows you to take classes that actually interest you. So you can take classes in the areas of artificial intelligence, neural network, uh, if you are interested in swarm robotics, and so on. So looking at MSRAS, this is the current structure. And please note that we have made some good changes to the program. So the core classes are MAE 501 and MAE 547, and we would be offering alternative classes for the linear algebra and modeling and control of robots that could be more relevant and sort of tuned to the background of electrical engineering, and your advising can help you selecting those classes. Then there are 2 concentration classes. One is the linear systems and then the multivariable controls. And then what you can do is you can select additional classes. We have a lot of courses as electives, and I would encourage you to take a look at our list of electives. You can talk to me, you can talk to your advisor, and we'll help you select good classes. Faculty working in robotics at ASU is a strong, thriving community. We work in the areas of UAVs, UGVs, wearable robotics, human-robot teaming, innovation and research, then human-centered design, and automation. So all these areas are very relevant for from industrial aspects, as well as if you are interested in pursuing PhD later, then all these subjects and classes will give you solid foundation to be successful. Now, if you want to take a look at what's happening at robotics, so this is the website robotics.asu.edu, and there are lots and lots of research topics with lots of faculty working collaboratively within ASU and outside ASU. You are welcome to reach out to them and then see what research they are working on. As you know, robotics is growing and it's expected 9% job growth. And to be honest with you, with this booming field, you can expect to land a job in Amazon Robotics, Google, or Tesla, or there are a lot of new industries coming around Arizona. As you know, TSMC is coming to Arizona. Then Lucid Motors, they're competing with Tesla, is coming to Arizona. So I would expect a lot of jobs to be available in next couple of years. We also have fantastic facility. We have the largest drone studio, indoor drone studio for academic research. You will get access to that and you'll be able to work on some cool robots. I'm the program chair for the Robotics and Autonomous Systems, and I will type my email in the chat window. You are welcome to send me an email if you have any questions, or you are welcome to go to the website and see what information is out there and reach out to your advising, and they will be able to help you. And thank you all, and thank you very much for the advising staff for organizing this event. And if you have any questions, I would be happy to answer. Thank you.
Thank you, Dr. Rodkar. So we do have a couple of questions that have come up in chat. I think we have a few of the faculty still with us, so I'll jump into those. Anthony is, Dr. Abley, are you still there? I'm not sure he is, so I'll do my best with this one. But Anthony's asking, he's thinking about entering a law school to study IP after getting his EE degree. Do you think there'd be a benefit to having a master's degree if he wants to be an IP person? I think generally a master's degree in general is going to give you more specific expertise in a specific EE area. So maybe that could apply that way. Hey, Dr. Averly, do you have any comments on that question?
Yeah, most of the IP lawyers that I know do not have master's degrees. However, I do know of at least one that has both a PhD and a law degree. So I think it really is, I don't think it's necessary. It may end up being helpful. It's really, if you're highly interested in a very specific area, then perhaps, yes. The thing about being an IP lawyer, sorry if I'm talking too much, but these ideas, these thoughts just pop into my head here. The thing about being an IP lawyer is you got to be kind of a generalist, right? You can't be, like somebody like me, very specific expertise. You need to have a more general ability to understand engineering concepts in general. Now, that doesn't mean that the master's degree would get in your way. It might help, but I don't know that it's necessary. By the way, I was there. I just couldn't find my headset. I had the meeting on speaker, and I was searching all over to find my microphone.
That sounds like an excuse a student would give, Dr. Aben.
Well, you can fail me for the seminar. What can I say?
Dr. Redcar, if you're still there, we do have a student asking about the benefits, the real benefit of studying robotics and autonomous systems versus a controls master's degree in EE. Do you have any comments on that?
Right. So to be honest with you, it may seem like there are a lot of classes that are shared, but when you are in a robotics field, you'll be studying controls from more applied point of view, specifically to the robotic systems or to the mechatronic systems. And in general, if you look at the control theory can be studied from purely theoretical point of view and from mathematical point of view. It can be studied from applied controls point of view, or it can be studied from integrating systems engineering, mechatronic systems, that aspect. So it totally depends upon what you're interested in. And controls is an important part of robotics. As a matter of fact, controls is an important part of a lot of electromechanical systems. So it's totally what your interests are. So if you're interested in building robots and controlling them and want to know more about how controls are applicable to robotic systems, robotics, MS in robotics and autonomous system is a way to go. But if you want to become a general controls engineer who understands the linear, nonlinear control theory and its application to not only robotic systems, but a lot of systems like aerospace or maybe marine systems or maybe cooling systems, automotive systems, then perhaps you want to be a generalist and you can pursue a degree in control systems engineering. But either ways, both of these programs are very good. It totally depends upon what your interests are. I hope that answers your question, Chase.
Yes, thank you very much. I think in the end, what you're hearing is a lot of students wonder what to do next, and if you should start with the interest first. I mean, it's important to make money. It's important to be successful and be able to provide for yourself and your family, but starting with the interest first is the most important. Even if you're going in an area that might be in less demand, those who have the interest always rise to the top in my personal experience. So thank you very much for attending. I think we've gotten through most of the questions. Thanks very much to Dr. Aberle, Dr. Redcar, Dr. Pillay, Dr. Reislein, Annalisa, and Lynn for presenting today. Oh, and Cheryl for arranging. Sorry, Cheryl. And then Cheryl.
I wasn't
Cheryl,
even
should
thinking
mention-
about getting thanked, but you're quite welcome.
Yeah, Cheryl, I should also, there was a question earlier about when the Pathways on Senior Design is. I forgot the date of that. Do you know?
It's next week.
Oh, perfect. So
I responded in the chat room.
I think that was for Anthony. So Anthony, you'll join us next week. You'll get to know more about Senior Design.
Yes, you'll get my annoying reminders in your email. Don't worry.
I think we're good then. So thank you all for attending. We appreciate your time.
Yes.
Thank you for putting
Thank
it
you,
on.
everyone.
Thank you.